Section 4.3, Complements and Conditional Probability. When finding the probability of some event occurring at least once, we should understand the following. At least one has the same meaning as one or more. The complement of getting at least one particular event is that you get no occurrences of that event. Finding the probability of getting at least one of some event, we're going to let A be the event of getting at least one of some event, and then A complement is getting none of the event being considered. To find the probability of A complement in this case, we're going to find that as the probability subtracted from 1. So the probability of at least one occurrence of the event A is 1 minus the probability of no occurrences of the event A. Now let's do an example to explain this. A study by Square Trade found that 6% of damaged iPads were damaged by backpacks and bags. If 20 damaged iPads are randomly selected, find the probability of getting at least one that was damaged by a bag or a backpack. Is the probability high enough so that we can be reasonably sure of getting at least one iPad damaged by a bag or backpack? So we're going to let A be the event that at least one of the 20 damaged iPads was damaged by a bag or a backpack. Identify the event that is the complement of A. So the complement of A is going to be not getting at least one iPad damaged by a bag or backpack among the 20. That means all 20 were damaged in some other way. So we want to find the probability of A complement, the probability that all 20 iPads were damaged in a way other than by a bag or backpack. So it was a 6% chance they were damaged by a bag or backpack, so 0.94 is the probability that they were damaged some other way. So we multiply 0.94 times itself 20 times, raise it to the 20th power, and we get a probability of 0.29. So therefore, the probability of the event A, which is the one we really want, is 1 minus 0.29 or 0.71. So for a group of 20 damaged iPads, there's about a 0.71 probability of getting at least one among those 20 that was damaged by a bag or a backpack. This probability is not very high, so to be reasonably sure of getting at least one, we might want to select more than 20 damaged iPads. Based on a poll, 69% of internet users are more careful about personal information when using public Wi-Fi. What is the probability that among 3 randomly selected users, at least one is more careful about personal information when using a public Wi-Fi? So this is another one of those at least one problems. We want to know what's the probability at least one of those 3 users is more careful. But we'll calculate it using the complement of that event. So the probability of at least one of the 3 users is going to be 1 minus the probability that none of them are careful. So the probability an internet user is not careful is going to be 1 minus the probability that they are careful. And that's going to be 1 minus 0.69 or 0.31. So the probability that at least one of the 3 is more careful is 1 minus the probability that none of them are careful. So 1 minus 0.3 times itself 3 times. So 1 minus 0.02971, which is equal to 0.97. Conditional probability is the probability of an event obtained with some additional information that some other event has already occurred. And we use this notation, which we saw in the previous section. The probability of event B given that small vertical bar denotes the words given that, event A has already occurred. The conditional probability of B occurring given A has occurred can be found by assuming that event A has occurred and then calculating the probability that B will occur. And here's the formula. And the way to remember this is whatever you're conditioning on, that probability becomes the probability in the denominator. Basically what we're doing in a particular situation is only considering the outcomes that are in event A and then considering how many of those also satisfy event B. And we'll do that with an example as we see here. So if one of the 555 test subjects is randomly selected from this table of pre-employment drug screening data, find the probability the subject had a positive test result given they actually used drugs. That is, find the probability of a positive test result given they used drugs. And so we notice here using drugs is the first row of the table, and there's 50 of those, and the probability that they had a positive result there was 45. 45 of those did, rather. And then the second part of it is going to be finding the probability that they use drugs given a positive test result, which is meaning we're going to deal with a column of positive results, which is 70, and how many of those had used drugs was 45, and that's going to be the conditional probability. So for part A, the intuitive approach, we want the probability of a positive result given the subject uses drugs. And we're looking at the first row again. And so we notice here there's 50 subjects who use drugs, and of those 50, 45 had a positive result. So 45 over 50 is 0.9. The more formal approach is using the formula that we showed before. And so if we notice in the table, there's going to be 555 subjects. 45 of those used drugs and had a positive result. That's going to be the numerator. The denominator is going to be the probability of using drugs, which is 50 over 555. We put that into our formula, and we actually come out with the same answer, basically the intuitive way, which is a much, I think, more intuitive. It just makes more sense. You don't have to worry about the total sample size because you're focused on a subgroup of the table, and I like that approach much better. So comparing the intuitive to the formal, it's clear that the intuitive is much easier to use and also less likely to give you errors. Now we want to know the probability that the subject uses drugs given they had a positive test result. So if we go back to the table, we have 70 people with positive results. 45 of those use drugs. So the probability that they use drugs given a positive result, 45 over 70, or 0.643. So the first result, these are different probabilities now. The first one was a positive result given they used drugs, 0.9. The second result was the probability that they used drugs given they had a positive result. So a little bit different question that we're asking each time. And they're not equal to one another. You can't switch the order of the conditioning and get the same answer generally. Use the results below from tests of an experiment to test the effectiveness of an experimental vaccine for children to answer the following questions. So here's the data. They were looking at flu vaccine, and we have a vaccinated group, a placebo group, a group that got flu, and a group that didn't get flu. If we select one child at random, what's the probability they develop flu? So out of the table of 1,602 children, 109 developed flu. If we select one child at random, what's the probability they develop flu given they had the vaccine? So we're looking at the first row here. So of 10,070, 14 of those got the flu. So it's 0.0131. If we select one child at random, what's the probability they got flu if they were given the placebo? So 532 had the placebo, 95 of those got the flu. Now, if you notice here, the probability of getting the flu given you had the vaccine was a little bit more than 1%, but the probability of getting the flu given you didn't get the vaccine now is almost 18%. What does this tell us about the vaccine? It might be working. It appears to be effective.